Sir.
Just a minute.
Yeah. Good evening, sir.
Good evening. A car is traveling on a straight or level road with uniform speed 60 kilometers per hour. It is followed by another car B, which is moving with a speed of 70 kilometers per hour. And the distance between them is 2.5 kilometer. Car B is given in a deceleration 20 kilometers per hour square. After what distance and time will the B catch up with E? First, what you have to do is you have to draw a small diagram to understand the situation. So it's a straight line motion, straight road. Car A, 60 kilometers per uniform speed, and followed by, so it's B is behind, obviously it should have a higher speed to catch up with E. So E is ahead.
Yes, sir.
Z, and B is behind it. So this is moving with a velocity of 60 kilometers per hour. This one is 70. When the distance between the two is 2.5 kilometers, B is given a deceleration of, it's 2 or what, 20. Deceleration 2.5 kilometers. So let me take that instant when it is separated by 2.5 kilometers. The acceleration of this thing is minus, because deceleration. What is the value? I'm not able to see that value properly. It's 2.5 or 20 or 2. I think it's 20. If it is wrong, tell me. You are
Sir,
might
sir,
wrong.
it's 2.5. It's 2.5.
No, distance is 2.5. The deceleration of this one, B,
Okay, like deceleration is 20 kilometer per hour.
per
Square.
hour square.
Yeah.
Okay. So at some stage when it comes here, he would have come here. At the same time, B would have come here. That's possible because B has got higher velocity, and also even though deceleration is there, but it has enough initial high velocity for that to catch. It is possible. First, when it is possible, the distance traveled by both. With if we take this as reference for my x-axis, this is x. This is the origin of the x-axis. Displacement of B when it is catching up will be equal to displacement of A plus how much? This will be in kilometers. Is that clear?
My mic is in mute. Yes, sir.
So when it is catching up at that particular time, let that time be T1. Okay. So is SA at that, for that particular time, SA is from here to here. And SB is from here to here. So both should be equal if it is possible for them to catch. So now AC is just uniform velocity into the time. That is 60 kilometers per hour into the time t1. T1 is the time when this t time 0 is the time when the distance between the two is 2.5. From that time starting the clock. And t1 is the time when they are catching up. And SB is ut, that is 70 t1 minus half 20 t1 square plus 2.5. So this is the only key step. Because AC is uniform velocity, just the distance traveled, that uniform velocity in the time. And for B, it's uniform deceleration. So it's ut minus half at square. Or plus half at square, where E is negative. Okay, so this we have to solve. So if we take it to right side, 10 t1 square minus 10 t1 plus 2.5 equal to 0. So that is 4 t1 square minus 4 t1 plus 1. So this is a quadratic equation 4. When I split into factors, it should give me minus 4. So it's minus 2, minus 2. So t1 minus 2, t1 minus 2 the whole square. No. It's 2t1.
Both are traveling in same direction, sir.
Yeah.
So like both displacement we can take common. Both speeds can be minus
No.
minus with each other. Then we can get 10 kilometers per hour like that.
No. Why do you want to do such things? See, this is my origin of the x-axis. No. Okay.
Yes, sir.
And towards right is positive. When towards right is positive, both the initial velocities are positive only. Only the acceleration is negative. Okay, so first let me check the answer. So T1 is it half an hour? Answer is T1 equal to half.
Sir, can we take average speed for both of them?
And do what?
And get the common speed and divide it by the displacement to get the time.
No, this is the important logic. Okay. In other words, you can solve by relative velocity. In that case, you assume you attach your frame to one of the thing to A. That will come later.
Not only the taking it now, relative speed, relative velocity.
That will come later. Okay.
Yeah. Okay.
This is the key step here in this problem.
Okay.
So first step is to draw a figure to understand what's going on. Once you have this figure, you'll be clear to get this step. Okay. So at time t1, this should happen. Both should meet. Okay. They're going side by side. Otherwise, they will collide. Okay. So in that case, my time t equal to 0 starts at this instant. They're separated by 2.5. That is the time starting the clock. So according to this clock, when the time is t1, they will come here and met. Okay, so let that time be t1. So from this initial time, the distance traveled by AC will be this much, and during that time, the distance traveled by B will be this much, and B has to travel extra distance of 2.5 because it's starting behind this A at a distance of 2.5. So displacement of B should be displacement of A plus 2.5. And displacement is uniform speed into T1. And for B, you have to use ut plus half at square. A is a negative value because of deceleration. Answer is correct, half.
I think so. Wait, I'll check. The
Oh,
half is not given here, sir.
okay, I made a mistake then.
Yeah, probably.
Thickest 4 hours. What is the correct option? half an hour one option is there, option
My
one.
mic is muted. 4 kilometers, 2 hours, I think. Wait, half an hour option, sir. I think option on 32.5 kilometer, 0.5 hours.
Hold on. This 2t minus 1 4 square is 4t1 square minus 2 times this one plus 1. So this
Yeah.
is, so t1 is half is correct. Okay, the distance traveled. What is the question? Distance, after what distance and time will B catch up with A. So after what distance means this is A or is B? To what distance? So basically AC. So 60 into half, so it's 30 kilometers. So after traveling a distance of 30 kilometers, A traveling a distance of 30 kilometers, it will catch up. I 32.5. In half an hour. Okay, suppose I take the distance traveled. So yeah, 30 by this A and 30 plus 2.5 by the B. So B should travel a distance of 32.5. A will travel a distance of 30. Option 1 is correct. At what distance and time will B catch up with A? So distance started by B. Is it clear?
Yeah. They have given it as deceleration.
Deceleration is fine because the initial velocity
Yeah.
high, no?
Yeah.
The initial velocity is high enough, 70 is high enough. So in case if this size is not high, then maximum B would have come here, A would be here. After that, A will go and then B will come slowly. So the distance cannot become zero between these two. So there is a question mark whether it's possible or not. Here I'm getting it's possible because I'm getting an answer as T1 equal to half. If it's not possible, then I'll get T1 as negative value. Okay.
Time I'm getting as half, sir. I calculated.
You're getting what?
I'm getting time as half an hour.
Yeah, that's correct.
Yeah. And using this time, I'm finding distance is like,
Find distance solved by B.
yeah, 70 by half. 70 by 2 is equal to, yeah, is it 32.5?
Yeah,
Okay, then I found the answer.
yeah, fine. So next question.
Uh, the top one, an object falling through a fluid is observed to have acceleration. That question.
An object falling through a fluid is observed to have an acceleration, okay, G minus BV, okay, where G is acceleration and B is a constant. After a long time of release, it is observed that yeah, this is terminal velocity concept. See, basically
Yes, sir.
the acceleration is G minus, actually, if this thing is not there, BV, then it's normal falling through gravity, A equal to G. Okay, but since this falling through a liquid fluid, it'll have a damping force or a friction force, which is minus BV. So you just have to draw a diagram. So this is the object. So uh, okay, so it's falling. So the force acting on this is the weight mg. Okay, and then the viscous force. What we have to find out? Okay, the constant speed. Uh, so when the speed is constant, acceleration. So the speed. Let me explain the concept. See, when a body is falling, say mass is falling, just there is no liquid surrounding it, then it's just gravity force, right? It's mg, there is an acceleration here. So the net downward force is mg, that's equal to mass into acceleration. From this, I'll get acceleration as g. But here in this case, the net downward force is mg minus the viscous force, which is b into v. So this is the net force acting on this body. G is a constant number, m is also constant, b is also a constant, but this v will keep on increasing as it moves down. Okay, at some stage, this net force will become zero. So when it becomes zero, when the net force is zero, acceleration will be how much? Zero, because net force is mass into acceleration.
Yeah.
F net equal to mass into
Zero.
acceleration. So acceleration.
Mass into acceleration. So F net is
if
zero,
we equate,
acceleration also.
yeah, if we equate this to zero, that will give me a speed as v as mg by b. So when the body attains this speed, net force is zero. So after that, it will stop accelerating. So this is the speed. We have to put the numbers. Okay, numbers are not required. Just mg by b. Value of constant speed. This is the force. Okay, acceleration is g minus bv, right? I made a mistake. Acceleration is g minus bv. So force is mass into g minus bv. Okay, so when this is zero, so mass will not come. G by b. Option 1. Check the answer. Your mic is off.
Sorry. Sir, I think the answer is, I think it's B by G. Is it correct?
G by b. Acceleration
No,
has to
B
be
by
zero.
G.
Acceleration has to be zero. So that will give me v
Yeah.
as g by b.
Yeah. Yeah, G by B, yes.
Yeah, the thing you have to understand is when the net force is zero, it will stop accelerating. Sorry, velocity will keep, after that, the velocity will be constant. So for the net force to be zero, acceleration, mass into acceleration has to be zero. That means acceleration has to be zero. From the line there, velocity is this one. Clear? This is concept of terminal velocity. Like when a raindrop falls from a height, as it comes down, the velocity will keep on increasing. But as the velocity keeps on increasing, the resistance force, the viscous force will also keep on increasing. At some stage, both will be at balance. After that, the net force acting on the raindrop will be zero. So after the raindrop will fall with a constant speed. Next question.
Sir?
Yeah, your mic is not working or what?
Oh, okay.
So which question next one?
The question number 35, can you see, sir? It's kind of blurred, that's why.
The police van moving on a highway with the speed of 30 kilometers per hour from the burglar, from a bullet of a thief car speeding away from the direction in the. Oh, it's very bad. Take one more snap.
Sir,
Take one more snap
35th
because
one.
it's too blurred.
Yeah. So like they have
Mobile
given
will be
police
better.
one. Yeah,
Or you just read it out.
yeah. A police one moving on a highway with a speed of 30 kilometers per hour
Ah,
fires a bullet at a thief's car speeding away in the same direction
hmm,
with a speed of 192 kilometers per hour.
okay.
If the muzzle speed of the bullet is 150 kilometers per hour,
Hmm,
meter per second minus 1, the speed in which the bullet can hit the thief's car is. Sir, just a moment, sir.
yeah.
Sir, yes, sir, we
Yeah,
can continue.
yeah. Uh, so the okay, you just have to tell me. So the car is moving with a velocity of what? The police jeep.
The car is moving, uh, police van is moving on a highway with a
No,
speed
no,
of 30 kilometers per hour.
just a minute. 30 kilometers per hour. And this bullet is moving with the speed of, sorry, bike.
192 kilometers per hour.
That's a bike, no? 192.
No, 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 no. The speed of the thief's car
Okay,
is 192 kilometers per hour.
okay. And this bullet speed is,
Muzzle speed of the bullet is 150 meters per second.
how much is the velocity of the bullet? One?
150 meters per second.
Okay, this is a minor thing. Basically, it's the thief's. So crazy, man.
This is the question, sir.
Yeah. So basically, so you have to find the speed of the bullet when it hits the speed with which the bullet hits the thief's car.
Thief's car. So, like both of them are moving in the same direction. Can we use instantaneous velocity concept?
Hold on, not that's not the thing. Uh, Velocity of the bullet is 150. No, it's always instantaneous velocity only. The velocity, whether it's constant speed or it's going to change here. 150. First, let me convert this thing to get an idea what is going on.
All we can convert to meter per second now, sir.
No. Then you have to convert two of them.
So we have to convert this into kilometer per second.
So
Multiply it by 18 by 5.
150 when you convert to kilometers will become less.
18 by 5.
And per second, when you convert it to per hour, it will be more by 3600.
Can't we just divide by 18 by 5?
Yeah, same.
Sir, multiply.
Yeah. So 15 into 36, the bullet speed is much higher. So it is 360 plus half of 360 is 180. 4, 1. So 540 kilometers per hour. Okay, this is this thing with respect to the moving vehicle.
So now we have to minus those two speeds.
Now, first of all, this thing, this velocity of the bullet, this 540, what is it with respect to the ground or usually with respect to the car? So velocity of the bullet with respect to the police vehicle is 540. Okay, that means velocity of the bullet minus velocity of the police vehicle is 540. So velocity of the bullet with respect to the ground will be 540 plus 30, 570 kilometers per hour. So thief is going at 192, right? So velocity of the bullet with respect to thief when it hits it with respect to thief will be 570 minus 192.
Which is
8, 16 minus 9 is 7,
378.
378.
But that is not the answer. No, we have to convert the answer to meter per second, sir. They are in kilometers per hour. We have to divide the second by 5 by 18.
Yeah, it will become less.
378.
378 into. So 9 2s are
378 divided by 18 we have to do.
9 4s are 36, 42. So 21 into 5.
110. No, 105, 105. Option 2.
Yeah. Check the answer.
Yeah, it's option 2, sir.
Yeah. See, there are certain things you have to understand. Usually when they say the velocity of the muscle velocity or something, that with respect to the frame in which it is sitting. Okay.
Yeah.
So this 150 is actually whatever is given us, what I found 150, this thing is 540. That 540 is velocity of the bullet with respect to the frame, which is same as the police vehicle. Okay, so this means velocity of bullet minus the velocity of the police vehicle is 540. That means the velocity of the bullet with respect to the ground, which is stationary, is 570. And if it's going to hit this thing, it's going to be the relative velocity. So I have to find the velocity of the bullet with respect to. So one extreme case is suppose this thief was moving at 570, then the bullet will not hit him at all. Because both are whatever the initial distance. But since this thing is moving at 192 and the bullet is higher speed, 570, the bullet will catch up with the thief. Okay, and when it is catching him, it's just about to hit, the speed which will hit is the relative velocity.